channel. Today we'll be looking at the Intel 8085 microprocessor instruction set. The Intel 8085 microprocessor set is classified into 5 different categories. We have the data transfer group, we have the arithmetic group, we have the logical group, we have the branching group, and we have the control group. For this lecture series, we'll be looking at the arithmetic group. The arithmetic group is divided into 19 different instructions. For example, we can say instruction number 1, add register to accumulator. We can say instruction number 9, subtract memory from accumulator. We can say instruction number 10, subtract register from accumulator with borrow. And we can say instruction number 19, decimal adjust accumulator. But for this lecture, we'll be looking at instruction number 1, 2, and 3. So to explain this instruction better, we're going to be looking at some examples. So let us take example number 1. Add register to the content of the accumulator. Example 1. Assume that before the execution of any instruction, we have accumulator equals to 65 hexadecimal and the content of register L 50 hexadecimal. What is the value of register A and the value of the different flag after executing of add L? So the solution. The first thing you need to do, you need to convert what the accumulator 65 hexadecimal to binary, and this is the conversion. And we convert the register L 50 hexadecimal to binary, and this is the conversion. The next thing for us to do is to add. So we have 1 plus 0, we have 1, 0 plus 0, we have 0, 1 plus 0, we have 1, 0 plus 0, we have 0, 0 plus 1, we have 1, 1 plus 0, we have 0, 1, 1 plus 1, we have 2. But we cannot write down 2 because we are working in binary. So how many times 2 do we have inside 2? We have 1. What will be left? We have 0. So we put what is left here, which is 0. Then how many times we take it to D7 to continue the addition? So we have 1 plus 0, 1, 1 plus 0, 1. And this is the result we have. So we now convert this result here to hexadecimal. So what will be left in the accumulator after execution of that instruction will be A is equals to B5 in the hexadecimal. Then what will be the value of the 0 flag? The 0 flag is equals to 0 because the result of the operation is not equals to 0. Then the sign flag is equals to 1 because the bit D7 of the result is equals to 1. Then the carry flag is equals to 0 because there was no carry after performing the operation. Then the auxiliary carry flag is equals to 0 because there was no carry between D3 and D4. And the parity flag is equals to 0 because the number of ones we have in the result is odd. So we'll look at the next example. Add content of memory to content of the accumulator. So assume that before the execution of any instruction, we have the accumulator is equals to 35 hexadecimal, then H is equals to 20H and L is equals to 30H. Both H and L, they are register pair, and the content of the memory location 2030 is equals to 30. What is the value of register A and the value of the different flag after executing the instruction of add M? So the solution, the same way we convert the content of the accumulator to binary, also convert the content of the memory location to binary. So we now add. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 2, but we cannot put down 2 because we are working in binary. So how many 2 do we have inside 2? 1. What is left? 0. So we'll put what is left here, and that how many times, which is 1, we'll add it to this. 1 plus 1, 2, then 2 plus 1, 3. But we cannot put 3 here. So how many 2 do we have inside 3? We have 1. What is left? 1. Then bring that 1 here. Say 1 plus 0, 1. 1 plus 0, 1. Then we'll have 0 plus 0, 0. So this is the result of the operation. So the next thing is to convert this to hexadecimal, which will have 65H, which is the content of the accumulator after performing the operation. Then the 0 flag is equals to 0 because the result of the operation is not equals to 0. Then the sign flag is equals to 0 because the digit D7 of the result is equals to 0. Then the CY flag is equals to 0 because there was no carry after performing the operation. Then the auxiliary carry flag is equals to 0 because during the operation there was no carry between D3 and D4. Then the parity flag is equals to 1 because the number of ones we have in the result, they are even. Then the last one we're going to look at in this series is the add content of register, arrow and carry to content of the accumulator. So example 3, assume that before execution of any instruction, we have A is equals to 65H and B is equals to B2H, and the carry flag is set to 1. What is the value of register A and the content of the different flag after the execution of ADC B? So we have solution. So convert 65H to binary. We convert register B, which is B2H, to binary. Then we'll put our carry flag, which is equals to 1. So we'll now add 1 plus 0, 1 plus 1. We have 2. So how many 2 do we have inside 2? Is 1. What is left is 0. So bring the 1 here. 1 plus 0, 1. 1 plus 1, 2. 2 plus 0, 2. So we cannot put 2 here because we're working in base 2. So how many 2 do we have inside 2? We have 1. What is left? We're left with 0. So put the what is left here. Take the how many times to this? 1 plus 1, 1, 2. Then 2 plus 0, 2. 2 plus 0, 2. So how many 2 do we have inside 2? 1. What is left is 0. Then we'll take the 1 here. 1 plus 0, 1. 1 plus 0, 1. 1 plus 0, 1. Then we'll have 1 here. So 0 plus 1, 1. 1 plus 0, 1. Then we'll have 1 plus 1, 2. 2 plus 0, 2. So how many 2 do we have inside 2? Is 1. What is left is 0. Then we'll bring the 1 here. So we'll have 1 plus 1, 2. 2 plus 0, 2. 2 plus 0, 2. So how many 2 do we have inside 2? We have 1. What is left is 0. So bring the 2 here. 1 plus 1 here. 1 plus 0, 1. Then 1 plus 1, 2. 2 plus 0 is 2. So we cannot write 2 because we're working in base 2. So how many 2 do we have inside 2? 1. What will be left is 0. Then the how many times, which is the 1, will now be the carry. So after execution of this instruction, the accumulator is equals to 18H. Then the 0 flag is equals to 0 because the content of the result is not equals to 0. Then the sign flag is equals to 0 because digit D7 of the accumulator, the result is equals to 0. Then the CY flag is equals to 1 because there was a carry here after performing this operation. Then the auxiliary carry flag is equals to 0 because there was no carry between D3 and D4 during the operation. Then the parity flag is equals to 1 because the number of ones we have in the result, they are even. So you can try this exercise in order for you to get a clearer understanding of the lecture. So thank you very much. If you have this lecture very useful, you can like and leave your comment. Always follow me on this channel for more interesting lectures. Thank you.